Okay, hi, I'm Darren White and I'm the IoT Systems Engineer for Pragma. And for Pragma to become a smart enterprise asset management company, we have to enable our clients to put all the necessary systems in place to do so. And I've got Mauritz over here next to me, who also forms part of this IoT ecosystem at which we will help our clients in a different way.
Yes, like Darren said, I'm Mauritz Zastron. I'm the Business Intelligence Engineer at Pragma, and my responsibility is just to ensure that all our clients and users and even the employees have the tools that they need to perform their duties and to make sense of all this data that we're collecting and to apply it in a meaningful way. So briefly this morning we just discussed the whole Industry 4 and all the buzzwords and how they're interconnected. So it starts with the data acquisition using IoT. This is then used to create the digital twin, and in the cloud we can perform all kinds of cool transformations on the data. We can use machine learning, artificial intelligence, but then somehow once we've gotten to an answer we need to connect that back to the asset, and that's where virtual, augmented and mixed reality plays a role again. But I think we should maybe start with the data acquisition phase using IoT, and Darren can maybe just elaborate on that a bit.
Yes, yeah. So what Mauritz explained is quite intimidating because it's quite a big, loop of systems. And now to start, you have to collect the data, and to collect the data, you have to be sensible about what sensors you choose. And this is the portion I call the edge to cloud, and which is referred to where edge is the area which is near the source of the data, and the cloud is the area or platform where the data is processed, it's displayed, and it is stored. Now, to get this right, there are various steps that you need to take. And first of all, if you've collected the data by using smart sensors, and what I mean by smart is that your transducer or your actuator, if you want to control assets, they need to be combined with processing and communications features, and you have to ensure that your communications interface is well suited for your application and your environment. So once you've collected the data, and then you have to transform that data, and typically your gateways, your IoT gateway or your smart sensors takes over this responsibility. And so what this means is the data needs to be streamed, it needs to be filtered, and if you are clever about choosing which data must be sent to the cloud, obviously due to significant cost implications for data transferring, and you have to look at your protocols that you want to use, and that applies to both your sensor to edge communication as well as your edge to the cloud communication. And it's where the term interoperability becomes quite important in the industry, where the changing or the sharing of data in between system and devices can become quite challenging, and your gateway must be able to accommodate that. So once you've got that right, you have to transfer that data to the cloud. And your typical connectivity methods can range from Ethernet, Wi-Fi, 4G, 3G, and GPRS, but with remote applications it becomes quite difficult to transfer that data, and in this case you can make use of IoT specific networks like LoRa and Sigfox and RPMA or Vodacom's narrowband IoT. So so now you've got the data in the cloud, and you need to get some useful and insightful information, and you need to get some value out of it, and there needs to be some action. And I think Mauritz can explain this quite well for us. And what do we do with this data, and how can we get some value out of it?
Yes, and I think traditionally we've just been using two-dimensional communication, so we've got nice dashboards and graphs and insights, but we need to adopt to Industry 4. Industry 4 is going to require us to use this information that's stored in a two-dimensional format in a three-dimensional world. And some technologies that can help us with that are mixed reality, augmented reality, and virtual reality. And I just quickly want to give a definition of each, because the words are often confused with each other. The technologies are used interchangeably, and there's actually a specific application of each one in industry. So virtual reality is a digitally generated world. So if you think of the VR headsets that you can pop your phone into and it turns your office chair into a roller coaster, that's a typical application of virtual reality. Augmented reality is an environment that's been modified so that digital information is superimposed over the real world in real time. So virtual reality replaces the real world, whereas augmented reality enriches the real world. And then we've got mixed reality, which is where these two technologies are almost combined to add digitally generated computer objects which do not exist to the real world. So if you think about the Pokemon Go game, that was such a crazy thing 2 years ago, where you could just have different Pokemons running around in a conference room, for example. And then I think we've got lots of application of these technologies in industry, but the first one that jumps to mind is safety. If you can overlay safety information about assets and environments onto them, then you can steer artisans and operators and engineers clear of these hazardous environments. And then, I mean, you can lock permit work, for example. You can provide training in a safe and controlled digital environment or virtual environment, which simulates a real world, but which does not pose any of the real risks. And then, I briefly touched on it now, but training is going to be hit by this quite hard as well. As soon as technology becomes cheaper and the bandwidth capabilities of networks becomes better, we'll be able to give people training remotely. We'll be able to disassemble assets without touching a single wrench. And then finally, the way maintenance is executed and planned will also be changed dramatically. The OEMs will have to play their part, but I mean, all of a sudden you can project steps for maintenance onto an asset, and the operator or the engineer or the artisan even can be guided through the operation of the asset, and then also the maintenance of the asset. And then finally, the concept of experience leveraging also start playing a role, where experts can assist less experienced workers in the field remotely and walk them through tasks and make annotations to their real world views.
Yeah, and I think you touch quite an important topic in terms of training, where a lady from ESCOM did a really good presentation, where she said that the training effectiveness improved by as much as 60%.
Yes.
So that's a question that I've been asked quite a couple of times, and where clients come up to me and they say, well, what is the investment for IoT applications, and do I have to replace machinery, do I have to replace systems in my PLCs? And the answer is no. And that's the nice thing about IoT, is you can make use of your existing sensors that are installed on your assets. And you know, a good example is you can pull data from your PLC systems or your sensors that are configured via your PLC, where you don't need those extra sensors. And I think to start off is you got to have an adoption plan and look at your strategy, but start small. Start with a thin slice type of project and look at your existing sense or existing assets where you can pull your data from, and to obviously get it through a gateway and then send it to some cloud platform. So yes, I think it can be quite easy to start. There will be some upfront costs involved, but it is not a case of replacing technologies or replacing assets, in an extreme setting. So and I think it's quite easily achievable.
And I think the one thing that we just need to point out is that you don't need to buy IoT enabled assets now. You can give your old assets a voice using technologies such as the Raptor Gateway, where you can connect almost, let's call it open source sensors to it. So once you've got those old assets up and running, you can see where you can improve. And I think it's important what Darren mentioned is to start small, see where you can get the most bang for your buck. And because you're going to need some buy-in from the business as well. So if you can get that right from the start, then I think the adoption of IoT is going to be massive. And then also just make sure that whatever you choose as your proof of concept is scalable, because you don't want to do all the hard work and then realize that you can't do this on a bigger scale if that is your implementation plan.
No, you're right, Mauritz, and I think also one big challenge that we're facing is that people don't want to share the data, or companies and OEMs and service providers, they tend to hold on to that data, but for very good reason. And one of these reasons is that they can control their customer, and any competitive threats can have their access restricted. So it's quite a challenge in the industry. And if you walk into a big industrial company, you've got these teams of engineers and technicians where each of them have different dashboards, they've got different applications, and communication across these systems and various groups. This is done in a manual operation, either being its phone, email, or sharing of files. So yeah, that can become quite difficult. And when you adopt an IoT plan, make sure that your systems are open as far as possible and practical, and make sure that your gateways are interoperable and it can share data in between all types of systems and devices.